from the set. Does anybody have any questions on those? They're pretty easy, so if you don't, that's normal. Anybody with anything? Nada? We're good? We can always come back and get them another time if you... 14? Okay, sure, we can look at 14. Oops. Oh, okay. So 14, I am just going to think about this geometrically. So like negative 4i would be here on the complex plane, right? Yeah. So the absolute value of negative 4i is just going to be 1, 2, 3, 4 units. Cool. And the theta is going to be, what angle is that? 270, or since it's asking it between 0 and 2 pi, 3 pi over 2. So I'll just say 4 times cosine 3 pi over 2 plus I sine 3 pi over 2. Done. Oh, well, it's because there's only one component to it. And you're trying to do like, well, I was going to do the square root of a squared plus b squared. And you can do that. A is 0 and b is negative 4. But like, if you just think about the picture, it's like, yeah, man, like that's super easy. And you could do that the same way for like 13, 14, 15, 16. All could be done that kind of the same way. If you just have one component, you just draw the picture and that's all you really need. You know what I mean? Yeah. Sergio, you should be putting your cell phone away. Thanks, dude. Josie.
Can you please do number 38?
Yeah, man. So 38, the directions ask you to write this in standard form and put it in exact form if possible. So the thing that I really want to look at is the angle measure involved. 220 or negative 228 is not a unit circle value. So this is a pure calculator problem. So I'm just going to fire up my calculator, check to make sure I'm in degree mode since my angles are in degrees. And then I'm just going to do 2 times cosine negative 228. So there's my A value, and then 2 times sine negative 228. So there's my B value. So I have negative 1.34 plus, what was it? I forget now. 1.49 I. And I'm done. Yeah, so if there's no, if it's not a unit circle problem, it's just like a pure calculator problem. Just type it in, press enter, and bada boom, bada bing.
Cool, thank you.
Yeah, no problem, dudes. Anybody else? No? Okay, fair enough. Today, we're going to do 11.2. So this is multiplication division for complex numbers. So we're going to go back in time. Remember last year we talked about multiplying complex numbers in standard form. So for example, if you had something like 3 minus 2i times negative 4 plus 5i, and want to multiply that out, what do we have to do to multiply that out? What's that? Yeah, that's right. We're going to FOIL. So 3 times negative 4 is negative 12. 3 times 5i is 15i. Negative 2i times negative 4 is positive 8i. And negative 2i times 5i is negative 10i squared. Everybody cool with that foiling? Hopefully you notice that, hey, there's an I squared there. What's I squared equal? Negative 1. Yep, we talked about that yesterday. You'll need to remember that. And now I can just combine like terms. So I have negative 12 minus a negative 10, so that's like negative 2. And then 15i plus 8i is 23i. Is that cool with you guys? So all really complex number multiplication kind of looks like just regular multiplication that we're accustomed to. There's one special case where you can have a shortcut. So if I have something like negative 3 plus 7i and negative 3 minus 7i, if you think back to last year, you might notice that, hey, this looks a lot like a difference of two squares. Pretty cool there. So instead of foiling on this one, I can just kind of, oops, 7i. I can do that. So 9 plus 49, or 58. How did I get 9 plus 49? 7 squared is 49, but why is it plus instead of minus? Negative 1 from the I squared, exactly right. Everybody cool with that? As a separate piece of vocabulary, these guys like this that have the different sign in the middle, we have a special name for these. They're called conjugates, or like they're the same binomial pair but with the opposite sign in the middle. God bless you. You're all. Does this all ring some bells? No big deal, right? We remember doing this from last year. Even last year, this was pretty easy, so like no big deal even. What if we wanted to do this instead in trigonometric form? Well, we'll hope that there's like a shortcut that we can discover. So to do that, let's do this kind of generally and see if we can discover a shortcut or a, something to make this process more efficient, because we could approach this the same way as the previous problem, but maybe there's an easier way through this. So let's just take two complex numbers, z1 and z2, that are defined generally. So I have r1 times cosine theta 1 plus I sine theta 1, and r2 times cosine 2 plus I sine theta 2. Everybody's okay with that? So we'll just kind of go about doing this generally. If I multiply the two together, well, I'd have the first thing times the second thing. Everybody's okay with that? I'd have done nothing here, really. If you take a look at that, do those brackets really need to be there? No, man, I'm just multiplying four things together, right? Like, the brackets don't need to be there, so let's just drop those. And since I'm just multiplying four things together, R1, a parenthesis, R2, and another parenthesis, does it matter the order in which I do that multiplication? Nah, man, right? We can multiply in any order we want. So what I'm going to do is I'm going to pull the R1 and R2 out front, and I'm going to leave the parentheses second. And just like I did before, I'm going to now just FOIL out these two parentheses. Mr. Kulak is not looking very promising right now. It's getting worse looking than what we started with. Well, it's always darkest before the dawn, they say. Let's see if we can clean this up at all. I noticed I got an I squared here. What's I squared? -1. So I noticed that inside that parenthesis, I have two terms that have i's in it and two terms without i's in it. I'm going to go ahead and group those terms together. So the stuff without i's is the first term, and then the last term. And the stuff with i's is those middle two. It's like, all right, so what, Mr. Kulik? That still didn't look any better. Look closely. This is something you should recognize. Does anybody recognize that? That is an identity. That is the cosine of the sum of two angles. How about this one? Is that something you recognize? That's the sine of the sum of two angles. And Mr. Gulick, that is muy bueno right there. That becomes one Mac Daddy of a shortcut. Because what are we really saying then to multiply two complex numbers in trigonometric form? What do we got to do? Multiply the r's together and add the thetas. Mental math problem. Let's do a concrete example just to kind of hammer that home. All right, let's say we have Z1, which is 4 times cosine of 172 plus I sine 172. And we have Z2, which is 7 times cosine 13 plus I times sine 13. And we want to multiply these together. If we use the formula we just developed, that's going to be 4 times 7 times cosine of 172 plus 13 plus I sine 172 plus 13. Or really just 28 cosine 185 plus I sine 185. Holy simoleons, Mr. Kulak. Did these just turn into like straight up mental math problems? Like multiplication and addition is all I got to do for like real number? Like, holy snikes, that's pretty freaking sweet. So that becomes a pretty easy problem now, right? We had to jump through some hurdles to get the formula, but like once we got the formula, smooth sailing ahead. Feel okay? All right. Let's go back to last year again, and we'll do division of complex numbers in standard form. So if we have two complex numbers that are being divided, so like negative 3 plus 7i divided by 5 minus 8i, the way that I like to think about this is really as a division, or this division problem as a fraction. Everybody's okay with that? Right, fraction's the same as division. Everybody agree? Okay. The issue with what we've written as a fraction, the reason we're not done here, is a complex number needs to be in the form, or a standard form complex number needs to be a plus bi, right? So the issue is that we have an I in the denominator. That's the piece that we have to reconcile in order to get this into standard form. Does anybody remember how to get that I out of there? Great. So John says we're going to multiply by the conjugate of the denominator. So we're going to multiply the top and bottom of this fraction by 5 plus 8i. Important that we multiply that to the top and bottom, because really we're just multiplying by 1 here, right? Which is fine. Doesn't change the value of the fraction. So we need to FOIL out the numerator. So negative 15 minus 24i plus 35i plus 56i squared. And then on the bottom, we're going to have 25 plus 64. Again, I just used the difference of two squares to do that quickly. If you wanted to FOIL that out, you're more than welcome to it. You'll get the same result. I like my way because it's a little bit quicker. And I like being efficient, also known as lazy. But I'm a work smarter, not harder kind of guy. So, anyways, continuing on. In the numerator, notice that we have an I squared. What's I squared? Negative 1. So negative 15 and negative 56 is negative 71. And then negative 24i plus 35i is 11i over 89. And really, if we want to be precise about this, the way you'd want to write this would be as two separate fractions. So it's really clear that we have a plus bi. That rings some bells. Again, that was something that we would have done last year in our Algebra 2 course. Everybody okay? Looks familiar? Okay. So what if we want to do division in the trigonometric form? Well, we could do the same thing that we did before and derive the formula for our shortcut, but you guys being the clever students you are, I have a pretty good feeling that you could guess this correctly, given what we know about the multiplication formula. Anybody want to take a stab at guessing what the division formula is going to be? Divide the r's, that's correct. And subtract the thetas. Yeah. That's correct. You guys did not let me down. Which, to me, is massively easier than that mess we just had to walk through there before. Let's do a numeric example just to kind of hammer this home. But again, super nice, because what it's basically happening here is we're just left with a mental math problem. So z1 is 14 times cosine of pi over 3 plus I sine pi over 3. z2 is 2 times cosine pi over 7 plus I sine pi over 7. And we're interested in z1 divided by z2. What should I write? Who can tell me? (14 over 2) or 7. I'm going to just write it as this and then we'll simplify afterwards. Cosine of pi over 3 minus pi over 7, right? Plus I sine pi over 3 minus pi over 7. So 14 over 2, that's easy. That's just 7. Pi over 3 minus pi over 7. What do I have to do there? Common denominator. There you go. What would the common denominator be? 21. So 7 pi over 21 minus 3 pi over 21 gives me 4 pi over 21. And it's the same problem in both places, right? Whoop. Done. So what's the observation that we want? What's the takeaway here? Which ones are easier to multiply and divide? The trigonometric form or the standard form? Trigonometric form, right? So if you prefer, even if you're given a standard form problem, what could you do? Convert it to trigonometric form, do the operation in trigonometric form, and then convert it back out to standard form. You could do that. And in fact, if I were like writing a computer program that had to deal with a lot of complex number operations, that's probably the way that I would do it, because it'd be much easier to code in the multiplication division rule here than it would be the multiplication division rule in standard form, where like telling the computer how to make a conjugate be potentially kind of complicated. Be a little bit careful on how you'd have to do that, as opposed to this where it's just like there's nothing really to do. You just pull the numbers and add them and multiply them and done. Not a big deal. Is everybody okay with what we've done here today? Sergio?
How exactly would you do that? How do you transfer standard form to trigonometric form?
That's what we did in section 1.
Yeah, I just forgot. Okay, really don't worry about that.
You know, like 3 plus 2i, you know, is like here. So this length is the r.
Oh, okay.
So the r is going to be 3 squared plus 2 squared. So 13, or square root 13. And this is the theta. So theta is going to equal alpha, which is just, in this case, the tan inverse of the absolute value of 2 over 3.
Yeah, that's my bad.
It's okay. So again, you could do that instead, or you can deal with the things in standard form. Either is fine, right? You're doing the same thing. It's just a matter of preference. This is where we're going to stop today. So at this point, you should be able to do up to 64 in the problem set. There's only 3 sections left in this, or there's only 3 sections in this chapter. What should you expect next week? Homework quiz.
Next class meeting.
I think that's probably a good bet. And then we'll finish section 3 next class also probably. We'll do the review day and maybe a test Friday, Monday next week, depending on A's and B's. Which would be good, like get that out of the way before spring break hits, you know? And then we can come back to spring break kind of fresh in with chapter 15. Johnny.
Do you always have to do the absolute value and add the correct?
That's, well, okay, so This is a careful question. This is the way that I've instructed you to do it. There's lots of ways to kind of obtain that angle. That's the way I like to do it, is to draw the picture and then just like do the absolute value, and we're going to either add or subtract 180 or 360.
What if you don't do the absolute value and you don't do any other angle stuff?
Yes, sometimes. Yeah. So remember, tan inverse is only going to give you an answer in these two quadrants. So if you have something over here, you're going to have to do some kind of an adjustment to get it over there. So if you get a negative answer, you know, like you're going to be one of these two quadrants, and then you have to decide whether you need to be adding 180 or 360. And then if you get a positive answer, it's going to lie in one of these two quadrants. So you need to figure out if you're adding 0 or 180. So you kind of need the picture either way. So just a matter of preference. Does that make sense?
Yeah.
Sergio? Yeah, of course. So we're stopping here.